I am going to demonstrate you some geometrical property with the help of folding some papers, folding or cutting some papers. So that papers are with you, and everyone has got 2 sheets of paper, right? So folding some papers. So I assume that everyone is familiar with some basic things. Everyone knows about what are parallel lines. Everyone knows, right? Everyone. Okay. And what are the theorem for congruency of a triangle? Everyone knows this? SAS, SAS, AAS, SSS, RHS, and is there any AAA?
No. That's
Good.
similarity.
Okay, yes, that's similarity. Good. I know I want that you should know some properties of similar triangle also. Do you know about what are similar triangles are?
Yes,
What are similar triangles?
they are similar to each other. That is ratio of the sides are
Ratio of the sides are same.
proportional.
Good. Proportion. Okay. So everyone knows what is the sum of the all angles of a triangle? 180. Right. So if I have a triangle ABC, let me call this angle as A, and let me call this angle as B, and this angle is C, right? But the sum of it, sum is 180 degree, right? Can you not prove this? You can prove this, right? So, how will you prove this?
Sir, make a parallel line.
Draw a parallel line to this, right? This is parallel to this, and this angle is equals to which angle? This one, right?
Yeah, exterior.
And this angle is equals to the upper angle. Good. And this is common. So this is 180, right? Okay. Now, from any sheet of this paper, just cut a triangle of any size. Any size of triangle, just cut it. Everyone has cut this triangle? Sorry? For that. So you have 2 sheets of paper, right? So from any one of the sheets, just cut a piece of triangle. Everyone has done this, right? So now leave the biggest side of this triangle, concentrate on the other 2 sides. Means this is the biggest side of this triangle. So what I have drawn like this, don't look at this. This one is the biggest side of this triangle. So look at these 2 sides. Let me call ABC. Now locate the middle point of AB. So how to do that? Just fold these 2 vertex like this, and make just a scratch. So this should be the middle point of AB. Everyone has done this? Just take this vertex A and this vertex B and just fold it together and just make a scratch. Everyone has done up to this? Everyone?
Yes.
Okay. Similarly, do it for the other side also, this side. How to do that? Just again make a scratch on this. Everyone has done this. So what I have done after this, I have just fixed the middle point of AB and AC. Let me call it D and E respectively. Now fold this upper half of this triangle, this vertex A, with respect to the line joining D and E. So you have made 2 points. You have made 2 points, and now fold the upper half with respect to the line joining D and E. Be careful, and if you do it carefully, you will see the vertex A will exactly touches to the base BC, right? Everyone has done up to this. Fold the upper half of the triangle vertex A with respect to this line DE. If you do it carefully, the vertex A will touch the base BC, right? So what I have done, this is DE, this is BC, and now A, the point A has other vertex and fold it such that it coincides with the previous vertex A, like this. So what I have done, take this vertex C, fold it such that this C A, like this, right? So what I have done now looks like this is D, E, A and B point comes together, C. Now do the same thing for the vertex C also. Just take the vertex C, just fold it. You will get a rectangle, right? And what you have got? You have got another thing also. So what you have got here? Yes, a straight line, and like this, A, B and C all come together. This is DE. They come to coincide to one point and coincide with one line also, right? Everyone is happy with this? Yes. Okay, thank you. So point A, B and C angle A, B, C meet to a point and coincide with a straight line. this this means angle A plus angle B plus angle C is 180, right? Okay, how does this work? Anyone can tell me? I have told you to just make some folds, and certainly these three angles come to a point and meet to a straight line. Sorry?
By a triangle.
Sorry?
By a triangle.
No, take any triangle. It is not true for right angle triangle. So sum of all the angles of a triangle is 180. It is true for any triangle. I have not taken any right angle triangle here. Okay, just let me tell you. So how does this come? Can I use this board?
Okay.
Okay.
Midpoint theorem.
Yes, midpoint theorem. I have used midpoint theorem here. So what I have done, okay, I think all of you know this theorem, right? Midpoint theorem, ABC. If here my AD divided by DB equals to AE divided by EC equals to, in my construction, AD divided by DB equals is 1. Good, because this is the middle point, right? So for that reason, DE should be parallel to which line?
BC.
Very good. DE should be parallel to BC. And there is one more thing.
D equal to half
D is
BC.
half of BC. Very good. D is half of BC, right? So when I have fold this vertex A with respect to this line DE, why this vertex A exactly comes to the base BC?
Again midpoint theorem.
It's an isosceles
No.
triangle.
Yeah, that will be
No,
for
it is
all
no isosceles triangle. So what I am asking to you, when I have fold this vertex A with respect to this DE, you see that this vertex A comes to the base, right? Base BC. So why is that true?
That's because again midpoint theorem.
Yes.
It will be equal to half BC.
Half BC. Okay. This is because
Midpoint of BC.
this height is equals to this height. So if I now draw A, B, C, and this is the middle point of D, E. Okay, draw a perpendicular from A to BC. Let me call it F. And draw a perpendicular from E to BC. Let me call it G. So can you see this? That let me call it H. Can you see AH equals to HF equals to EG?
Yes.
How can you see that? Sorry? Huh? Okay. Look at these two triangle AHE and EGC. So these two lines are parallel, right? That means this angle should be equals to which angle? A AED. Good. This one, right? And I have drawn a perpendicular from this point. For that reason, this is 90, and I have drawn a perpendicular from this point to this point. So this angle is also 90, right? And this side is equals to this side, right? So it is what? Congruent by AAS, right? So for that reason, AH should be equals to EG. Why this is true?
Yes, CPCD.
Huh?
Corresponding parts of congruent triangles.
Very good. Okay. So for that reason this vertex comes to the base, right? So now, and then what I have done, I have fold this vertex like this, right? So what I have done then, this is DE, this is BC, and this is A, right? So now look at this triangle AEC. This triangle have one property, AE equals to EC, right? For because I have cut that
Yeah, that
AE
midpoint. Yeah.
midpoint, so AE equals to EC.
Yeah.
That means
It's an assistant.
yes, and for that reason this angle should be equals to good this angle, right?
Yeah.
So when I have folded like this, that means I have folded with respect to a perpendicular,
They will be congruent.
right? They will be congruent because this one
Yeah, the
is
common line.
Yes, common line. Blah.
Yeah, it's common.
all of you agree with this, right?
Yes.
That these two triangles are congruent,
Yes.
right? And for that reason, okay, let me just write it. AKE is congruent to EKC, right? And for sorry, CKE, this one, EKC.
Same thing. How, sir? By what congruent?
Huh?
By what congruent?
It's the same thing.
That's the common.
This side is equals to this side, right?
Yes, yes. Sir,
Okay.
it's common, right?
This is right angle. This is right angle by AAS.
That's a common one. EK is a common.
EK is common.
Sir, then also there is no property
Sorry?
like SSA.
No. AAS.
Right angle.
AAS or RHS also.
RHS also, yeah.
This is R, this is H, it's same.
Yeah.
This is common S. So RHS. Right? So for that reason AK is equals to KC. So for that reason when I have fold this, so this point comes to A, right? And this angle is equals to this angle also, because this big triangle is a isosceles triangle. So for that reason this angle also coincides, right? That is true for this half also.
Okay.
So for this half the same logic.
Over there.
So for that reason, so all of you are satisfied with that the angle of three triangles is 180, right?
Yes.
Okay. By construction, who know this? Anyone knows how to trisect a line? You know.
Sir, by using
How to?
similarity.
Okay, can you do with only pencil, compass and ruler?
Yes, sir.
Huh?
Yes.
With pencil, compass and ruler, can you trisect and just a line? So how to bisect a line? If you have, if you have a line, so how to bisect it?
So, is it necessary that the line should be cut equally?
Hmm?
Is it necessary when trisecting a line, does the line should be cut equally?
Cut equally three
No,
parts.
no, yeah.
Cut equally three parts.
Sir, will we be supplied to the graph sheet?
Hmm?
Will we be supplied to the graph sheet?
Okay, you want to do it by a graph sheet. Construction by your geometry class construction. Okay, how to do that? Draw any line and draw any angle with pencil compass, right? So if, and similarly draw a angle here, the same angle, draw an angle here and draw a same angle here. Now take any arc length and cut it, and the same arc length and just cut this side. Similarly do this same arc length, cut it, and again from this same arc length. Now join these 2 points. My claim is that it trisects this line.
Similarity
between triangles. Similarity between triangles.
So, okay, you will prove me in the break session.
Yes, sir.
I will just ask you for this proof. Why that is true? Why that is the trisection of a line? Okay. Now, this is a rectangular sheet of paper, right? So from here, cut a square sheet of paper. How to do that? Just make it half. Okay, just make it half, and it is also a rectangle, right?
Yeah.
Now make a diagonal.
Yeah.
Good. And make a diagonal. Make a diagonal and then cut along this line, right? Okay. Everyone has cut this square piece of paper. Okay. Take your time. Done it?
Yeah.
Everyone has cut this square piece of paper. Everyone has done this? Okay. Now with your pen or pencil, make a line along this diagonal. Just draw a line along this diagonal. Like this. Like this also. Right? Everyone has drawn a line. Okay. Now fold with respect to the middle point of this side CD and AB. How to do that? Just do this one such that this line coincides with this line and this line coincides with this line, like this. Do it carefully. All of you have done this. So you have created two small rectangles, right, with respect to this line EF, right, and again draw a line along this folded line. Like this. Everyone has drawn this. So what I have done, this is A, B, C, D. This is, I have drawn E, F, right? Now fold along with the diagonal of this rectangle FBCE along EB. Fold it along EB, or just draw a line along EB. You can fold okay, once again I am just telling that just fold along the diagonal of this rectangle EFBC. This one. Just draw a line. Okay. Or you can draw a line also. Just draw a line like this. So after this, what I have done, this is my square, this is the rectangle EF. I have, oh, this is the first diagonal of this square, this is the another diagonal of this rectangle. Everyone has drawn up to this? Huh? Yes. Everyone? Yes. 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 Okay. Now draw, let me call this point as P. Right? Now draw a perpendicular from P to the base AB. How to do that? So if you fold the paper such that this line coincides with this line and it passes through P. So how can you do this? Just if you just look at the, just fold it in back side such that these two lines coincide like this and it goes through the point P like this. Just back side of this paper, fold it such that this line comes to this line and the line goes through this point P like this. Everyone has done this? Sorry?
So it does not coincide with P.
No, you can draw perpendicular from any point, right?
Yes.
So
does
that's
B need to meet F?
sorry.
Does B need to meet F?
P need to
B need to meet F.
B.
Need to meet F.
Doesn't
No. Just fold such that this is perpendicular. So you can do it by taking this piece of paper like this, such that this line passes through P. Then fold it once more with respect to this line like this and make another fold. Okay, let me tell you once again. I have fold it with respect to that perpendicular, right? And fold it once again with respect to this line. At first fold that perpendicular, create that perpendicular, again just fold it like this. Just draw this perpendicular and again once again fold like this. Everyone has done this? Okay. I'm not getting anything.
So it's
Trisected,
trisected.
sir.
Ah?
Diagonal is trisected.
No, not diagonal trisected.
Like,
Ah? Yeah, exactly.
Yeah.
Have you got anything? Which line gets trisected?
The diagonal of the square.
the side.
Not diagonal.
BD.
Even a diagonal.
Huh?
AC.
and C.
AC.
AC.
Not diagonal. You have just
Diagonal, sir. The diagonal and the side. Both are trisected. Having blue.
I'm not sure about that diagonal, but it is clearly seen that these lines are getting trisected because this fold, this fold, this fold.
So, no, sir. Even the diagonals are trisected.
Okay, okay.
because The ratios.
Okay, that may be true, but I am going to trisect this line AB. So you can see it clearly, right?
Yeah.
Right? So why that is true? Why it gets trisected? I have just told you to do some fold, do something, and you will get trisected. The line will get trisected. So okay, let me just erase it. Let me call it any name. A B C D E F G. So why that line gets trisected? What's the proof of this? What's the reason behind that? Anyone? Any guess? Anyone? So my claim is GB should be 1/3 of AB, and you will see this because this is 1/3. You exactly see this, right? So why that is true? What's the proof of that?
So we can use similarity.
Hmm?
Similarity again.
Yes.
Triangle
Okay.
is
What is proof? So look at this two triangle. This triangle EFB and triangle PGB. Right? They are similar. Why?
Same.
BPD.
Same.
Huh?
Same.
Because okay, this line is parallel to this line. Everyone agrees with this, right? Because both are perpendicular, right? For that reason, this angle is equals to
FEB.
good. This angle is equals to this angle, and this angle is common to both, and this is 90, right? So this big triangle and this small one are similar. So by the properties of similarity triangle, then I can write EF divided by PG equals 2, okay, let me call EF divided by FB should be equals to PG divided by GB. It is right? What I have written there? EF divided by FB should be equals to PG divided by GB. Right? Now, look at this triangle AGP. This small triangle. This angle is similar to which angle? Okay. What is this angle? It is how much? 45. Good.
Yeah, it's
Because it is bisecting a square. And for that same reason, this is also 45. Because I am drawing a perpendicular from here. Right?
And this is
And for that reason, AG should be equals to GP. Okay. AG equals to PG. Okay. Call it PG. Let it take X. AG equals to PG equals to X. And let me take the length of this square, side of this square, AB equals to CD equals to L. The length of this square is L, right? Now just put it. What is EF? EF is same as AD, right? AD is same as CD because it is a square. So it is L, right? What is FB? FB, this is half of AB because I have folded it half, right? So FB is L by 2. FB is L by 2, right? Everyone is following me?
Yes, sir.
Okay. And what is PG? PG is X. And what is GB? This is X, PG is X, AG is also X because of this. What is GB? This is
1 by 3.
AB minus X. AB minus X. AB minus X.
Yes.
AB minus
what is AB? AB is L.
1 by 3 L minus X.
L minus X. Right? So GB is AB minus AG and AG is X.
Yeah.
Now solve for X. I don't want to solve that. Tell me X equals to in terms of L.
12. X is 12.
X is
12.
at first that is not possible because X is inside L.
2 by 3 L.
L by 2.
2 by 3 L. 2 by 3 L.
2 by 3L,
2 by 3 L.
2 by 3L and another, any other answer?
2 by 3 L.
12 by 3. Everyone has done this? It's so simple. 2 by 3L. What? 2 by 3L. So how many 12 by 3? Raise your hand. Man, just solve for X. This is so simple for 10th standard. So good. X equals to twice L by 3. Right? Sorry?
DG should be L by 3.
DG should be L by 3. Good, very good. DG should be L minus 2L by 3. This is L by 3. For that reason, it is trisected. So now, how can you get the 1/5 of this line?
So with the first construction we can do make 5 equal marks. Then
No.
5
3 equals 1.
I want to do, wait, just tell. Okay, 3. So now the question is how to get 1/5 of this line. So the first class will over at what time? No. The first class.
10:15.
10:15. Oh, already it is over. Oh, you need a break?
No, sir.
So
No,
10
no,
minutes or
sir.
5 minutes?
No, sir.
We
Continue,
don't
sir.
want.
Huh?
Continue, sir.
Continue. Anyone need break for 5 minutes or 10 minutes? Anything? Continue. I'm not even getting bored. Okay. So how to
So instead
Get-
of making 2 marks, make 4
Huh?
arcs. Like instead of making 2 arcs like here,
I'm not making any arc there.
also like by folding paper or by construction.
Anything.
By
By construction you can just make 4 arcs.
4 arcs. is
Yeah.
drawing,
And by this, now 1/5. I have got this GB is 1/3. Now I want to get 1/5 of AB. So think it. I have told you to think 2 things, right? At first, that construction, why that should work, it is 1/3. So what I have done, I have drawn same angles and take same arc and again same arc and then join this. And the claim is this is 1/3 of this whole. And now the question is why does this work?
Sir, similarities.
Just prove it. Okay, not now.
break.
Break.
Yes.
You want break?
No, sir.
We'll prove a break.
Okay. Okay. Just and this one and how to get 1/5. I have got 1/3. How to get 1/5? Okay. My third thing, right? So if you have a right angle triangle, let me call it length is A, the height is A, and this is B, and hypotenuse is C.
A square
So
plus A square
A square plus B square equals to C square.
We
Good.
should prove it now, sir.
Huh?
We should prove it now.
Yes. And okay. You have on this small rectangular sheet of paper, right? So now make a square of this, like previous thing.
A small one or a big one?
Any square, make any square. And do it carefully or else you will not get the thing correctly. So make a square. Let me call it A, B, C, D. Okay, just name this square along the vertex. Just name it like that, A, B, C, D. Now fold this corner D, this vertex D, such that it touches the diagonal like this. So what I have told to do you, fold this vertex D such that it comes to, it touches the diagonal and make it like this. So what you have got, the figure should look like this. Everyone has got this, right? Everyone has got this?
Yes.
Hmm? Okay. Now this is my A. Now, okay, this is B, this is C, and this is the diagonal, right? Now fold this opposite vertex D such that it touches to the diagonal and touches to this point also. Everyone has got this. Fold this B such that it touches the diagonal and touches that point also, like everyone has done this. It should look like this one. This. Everyone is like this. Okay. Now draw lines with your pen or pencil along these lines. This one and this one also. Draw line along these lines. Draw line along this one and this one, this and this. All of you have drawn this line. All of you have drawn this line, right? And unfold it like this. So if you have drawn line properly, it will look like, the figure will look like this. Unfold it and have A, B, C, D, right? Everyone has got like this. Okay. Let me call this small length, we call A. Let me call E. And this small length DE is A. Let me call that A. And okay, let me call it F. And let me call this length BF is small b. Right? So I have told you this length is A, right? So when I have folded this side, that means this side A, when I have folded this point D along the diagonal, so now what is this length now? What is this length? Huh? Everyone agrees with this?
Yes.
Everyone? Yes. Good. This is also A, right? And this small quadrilateral is now a square. Good. Square of length A. So now I have done the same thing for the vertex B also, right? So if this is B, this is also B. So this is also a square of length B, right? And if this is A, this length should also be A. So let me write it here. This is A. Not write it here. If this is B, this is also B, right? Now, okay, let me call this one is G, this one is H. Then draw a line along GH. Just join GH. Everyone has done this?
Yes.
Okay. Now what I have done here, just let me name these things. Okay. 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 What I have done here, I have created a small square, a big square, and two rectangles. And this one is a right angle triangle, right? And here, this one is also a rectangle.
So you just draw it.
So if you draw a diagonal, just for your sake, it is a. Again, here there is two rectangular triangle, right angle triangle. These two are also right angle triangle, right? And the length are all the same, right? This is A, this is B, this is A, this is B, and this is A, this is B, right? And this angle is common to both, 90 degree. So that means these four triangles are good. These four triangles are congruent to each other, right? Okay, just let me write it. GHI. So angle in front side, triangle GIH, right? GIH is congruent to all four other right angled triangles, right? So now tell me, what is the area of this paper?
A plus B the whole square.
Yes, area of the front side what is this? Yes, A plus B whole square. So I can write this A square plus B square plus
AB.
yes, A square plus B square plus 2AB also. So that proves that also A plus B square, B whole square equals to A square plus B square plus 2AB. I am not going to that. So I can write it A square plus B square plus area of four triangles. I can write it, right?
Yeah, AB.
AB, AB. I can write it. The four triangles are 1, 2, 3, 4, right? And this is A square, this is B square, right?
Yeah.
Now fold the back side of this paper along the hypotenuse GH. Okay, let me just show you once again. fold the back side of this paper like this along the hypotenuse GH. Like this, and now look at the back side of this paper. Just rotate it and look at the back side of this paper. So how does it look? This is the front side. So this looks like this, right? This looks like this, right? Now draw line along this. Draw line along, okay, along this one, and this one. Draw a line along this triangle. Behind the seat. Behind the seat. Everyone has got this? You fold with respect to this hypotenuse in the back side. Now, behind the seat, back side of this paper, draw line along this triangle. Sorry? Huh? Yes. Everyone has drawn this? So just draw a line. Okay, you have named this square, right? A, B, C, D, like this. A, B, C, D, and this one also. E, F, G, H. Everyone has done that? Yes? Okay. Now in the back side, just name those corner where there is A, write just A prime. A prime means just, if in the back side it should be right A prime, and it is now the A prime should be here. A prime, B prime, this is B prime. Now C prime has come here. Just call them just prime. Where there is A, B, C, D in front side, just look at the back